Good day, everyone. But it can also create inequality. Welcome to Lesson in Our AI and Digital Governance if it is not handled with care. Today's topic is basic politician and searching. You're not expected to build these systems. At first glance, it might sound like you are expected to understand software engineers to ask the right questions and to protect the public interest. These two concepts in the next lesson and searching will explore how absolutely central to how government information, retrieve and process information in the digital age, access and experience in their digital lives. Every time a citizen looks up their pension record online, and remember, every time a tax office checks eligibility, you already understand public foundation delivers a result, sorting and searching. Now it's time to apply that understanding to leadership and policy. When these algorithms are efficient, government works better. When they are flawed or overloaded, public services slow down and people lose trust. So let's take some time today to understand what sorting and searching mean in computer systems, how they apply to governance, and what you as policymakers should know when these systems are being designed or procured. Let's begin with sorting. 1. What is sorting? Sorting means arranging data in a specific order, usually ascending or descending. Imagine a list of names. If you put them in alphabetical order, you've sorted them. If you order a list of citizens by date of birth, that's also sorting. Sorting helps make information easier to read, easier to search, and easier to analyze. Just as you might sort paper files in alphabetical or numerical order in a filing cabinet, computers sort digital records in structured ways to speed up access and processing. Here's a quick analogy. Think of a public library. Imagine if books weren't sorted by title, author, or subject, just randomly placed on shelves. It would be chaos. The same is true in a government database. Whether it's voter registration, medical records, or property tax files, sorting ensures that when someone searches for a record, they can find it quickly. Let me give you a simple example. Suppose the city database holds information on 100,000 residents. If the records are sorted by last name, a search for Suzuki will take a fraction of a second. If the list is unsorted, it could take much longer, especially during peak times or emergencies. 2. Types of sorting algorithms. Now, how does a computer sort data? There are many algorithms designed for this purpose. Let me introduce just a few, using everyday analogies to make the ideas clearer. First, there's something called bubble sort. It's very simple and very slow. Imagine you have a group of people standing in a line by height, but the line is all jumbled. Bubble sort goes through the line again and again, comparing each pair of people and swapping them if they're out of order. It repeats this until the whole line is sorted. This method is fine for a small number of items, but it's not efficient for large datasets like a national voter registry. A faster algorithm is called quick sort. It's more like asking everyone in the line to group themselves quickly by choosing a pivot person in the middle and splitting the rest into those taller and those shorter, then repeating that process inside each group. It's faster, more scalable, and is often used in real systems. The point is this: not all sorting algorithms are created equal. Some are simple but slow. Others are more complex but perform better at scale. This matters when governments are working with millions of records and when citizens are expecting instant access to their data. 3. What is searching? Let's now turn to the second half of today's lesson, searching. Searching means finding a specific item in a collection of data. If you're looking for a residence record, a birth certificate, or a land registration entry, your system needs to search. Again, let's think about the filing cabinet. If the papers are sorted, it's easy to find what you're looking for. If not, you have to go through them one by one. Computers work in a similar way. There are two basic types of search algorithms I want to introduce: linear search and binary search. For linear search, a linear search goes through a list one item at a time. If you're looking for someone named Yamoda, the system checks the first name, then the second, then the third, until it finds a match. This works fine for small datasets or when sorting is not possible. But for large datasets, it's very inefficient. Imagine searching through a database of 1 million health records using linear search. It would take too long to be practical, especially during a public health emergency. 5. Binary search. Now let's look at binary search. This is a much faster method, but it only works if the list is already sorted. Binary search works by dividing the list in half, checking the middle entry, and then deciding whether to look in the left or right half of the list. It repeats this process again and again, each time cutting the search space in half. This allows it to find the desired entry in a tiny fraction of the time it would take using a linear search. Here's a real-world analogy. Think of a phone book, an old-fashioned one. If you're looking for someone named Tanaka, you don't start at page 1 and go name by name. You flip to the middle, see where you are, and then flip to the appropriate half. That's binary search. This is exactly how fast, efficient digital systems operate when optimized. 6. Why it matters in government. So why are sorting and searching so important for policymakers? Because the speed and reliability of these basic operations determine how responsive government systems can be. If your digital systems cannot search quickly, citizens will face delays. If your records are not sorted or indexed properly, it may impact health response times, emergency alerts, voting rolls, or tax notifications. Let's say a flood warning is issued. Your system needs to identify and contact everyone in the affected zone. If that data is well organized, sorted by region and searchable by location, it can happen quickly. If not, minutes are lost, and in emergencies, minutes can mean lives. Even in non-emergency situations, delays in searching records can erode public trust. A citizen applying for a subsidy or a permit expects quick service. If the back-end system takes minutes to retrieve their information, or crashes because it can't handle the volume, that's a governance failure. 7. Real examples. Here are some real examples of how sorting and searching affect government services. In Estonia, a world leader in digital governance, public records are not just sorted, they're linked. Every citizen's health, tax, and education records are accessible through a national portal. Efficient searching means doctors can retrieve patient histories in seconds, and officials can confirm tax payments instantly. Contrast that with systems in which data is fragmented, unsorted, or not searchable in real time. In many places, even basic citizen services are delayed because systems rely on manual lookups or poorly indexed databases. During the COVID-19 pandemic, countries that had real-time searchable health records could issue vaccination certificates, identify high-risk patients, and allocate resources more quickly. Countries without those capabilities struggled. 8. What policymakers should know. As a policymaker, you may never design a sorting algorithm yourself, but you do decide how systems are procured, funded, and evaluated. You must ask: are the systems we're using scalable and efficient? Can they sort and search records quickly under pressure? Are we investing in infrastructure that will work in the long term? Are we building systems that can handle emergencies as well as daily operations? You should also support open standards and interoperability. If systems across departments sort and store data differently, searching across agencies becomes nearly impossible. That's why digital governance is not just about adopting new tools, but adopting shared logic. 9. Key takeaways. Let's summarize. Sorting is about organizing data. Searching is about retrieving it. Efficient algorithms make digital government systems faster, more responsive, and more citizen-friendly. Poor algorithms, or poorly implemented ones, lead to slow service, errors, and inefficiencies. As leaders, you must ensure that your digital systems are not just smart on the surface, but fast and intelligent at their core. 10. Final reflection. You might think of sorting and searching as background tasks, something for IT teams to worry about. But in truth, they are at the heart of public service delivery in the digital age. From disaster response to pension processing, from school placements to police databases, everything depends on how well we organize and retrieve information. And as the volume of public data grows, the ability to sort and search efficiently becomes a matter not just of convenience, but of equity and security. Thank you for being part of today's session. In our next lesson, we'll take this further and explore how problems are solved step by step using algorithmic logic. But for now, just remember: If you've ever used a library index or flipped through a phone book, you've already used the logic of sorting and searching. The challenge now is to ensure that our digital government systems do it at speed, at scale, and in the public interest. Thank you.